modeling using variation. The word variation just simply means comparison. We want to be able to compare x to y, say for example. But the only way that we can do that is there has to be a go-between, because obviously x is not y. That's why there's some kind of separation. You think about maybe comparing apples to oranges. Well, they've always told us you don't compare apples to oranges. You compare apples to apples and oranges to oranges. So if you're comparing apples to oranges, then what is the go-between link? That go-between is going to be the result of this so-called variation. And so we'll say that y varies as x. So we're saying something. Y is compared to x. Y is related to x. Well, you call that an equation. And that's all that means. But to be able to determine the exact variation, we introduce some constant. We call that the constant of proportionality. And so that's the go-between. So y is related to x by some constant. That is, y is equal to k times x. Let k be the constant, let's say, for example. And then from there, we can build the relationship. If there's a man and a woman, they're talking about getting married, well, obviously, men are different than women. But men and women have some similarities. But there has to be a go-between in that relationship. And what's the go-between? The go-between could be several things. What's his past? What's her past? Do those past experiences relate? Well, if they don't relate, that's fine. Let's talk about that to see if we can still work the relation out in terms of the family dynamic. What's his family dynamic? What's her family dynamic? Do they agree? So we talk about some kind of comparison. And that's just one. There are infinitely many comparisons that we can deal with. So today we talk about direct comparison, we talk about indirect comparison, and then we talk about joint comparison. So the direct comparison is simply saying that y is related to x. They're going in the same direction. As y increases, x increases. If y is decreasing, then x is decreasing. So we talk about direct comparison or direct variation. Talk about indirect. So that is that y is equal to k divided by x. That simply means that when x decreases, y increases. And if y is decreasing, x is increasing. So that's an indirect comparison. If one thing is getting bigger, the other thing is doing the opposite. So, and then you can have joint variation, where they just put everything in that basket, and you got some z is related to x and y, for example, and x can be doing its thing and y can be doing its thing. And so we talk about that joint comparison a little bit later on. Let us see. So the first is direct comparison. We say that y varies directly as x, or y varies directly with x, or y varies directly proportional to x. They all mean the same thing. So here, when we say that, we're talking about a direct comparison. You see that y there? Think about y as being in the numerator. See that x is also in the numerator. There is no fraction, so everything is up top. So that is that when y gets big, x gets big. They get big at the same time. If y gets small, x gets small. They get small at the same time. We call this a direct comparison. So in the problem, they're going to give you like these simple word problems, and what you're going to see is that something like y varies directly as x. Then you're going to write y equal to k times x. K is the constant of proportionality that must be determined. So what is k? We don't know, but we can find it. Right? We can't forget k, because k is that go-between link. It's what relates to apples to oranges. Apples is y, x are the oranges. Well, they're not related, but they can be related by some kind of constant of proportionality. There's some kind of unit that compares them. What are some very known fixed constants in nature? The number pi is a constant. The number e, the base number e, is a constant. And so we have those constants that were given to us. The Egyptians were somewhat metaphysical when they dealt with these certain numbers. Their terminology, which spilled into the Greek scientists and mathematicians, which they inherited from some of it from the Egyptians, they simply call those numbers transcendental. That is that man had no control of these numbers. These numbers just somehow existed as a part of nature, and so we can use them. So anyway, so the steps, it says write an equation that models the given English statement. So that is that when you see y varies directly as x, understand this, that here y and x are just generic terms. This y can be whatever the problem says. It may be the housing market varies directly with inflation. And I mean, it could be direct comparison or indirect comparison, but you could say the housing market varies directly with inflation. So that would be whatever you represent the housing market, let's say H, and if that's being directly related to inflation, let's say maybe I, so you would say H is equal to some K times I. That's how you would write that. So Y and X are just generic terms, but you're looking at the statement, Y varies directly as X, means that Y is equal to some K times X. Y varies proportionally to X, means the same thing. Y is equal to some K times X. The statement Y varies directly with X, saying the same thing. Y is equal to some K times X. So there, when you read that, you're going to write step one, you're going to write some generic equation, and then step number two simply says, in the problem, they're going to give you some information. They're not going to give you everything. They're going to give you two values if we're comparing two things. And so when they give you those two values, they may give you a value for X and a value for Y. They're giving you that so that you can determine the value for K. So we want to be able to find K. And then once you have found K is going to be some fixed number then. And then I'm going to rewrite the equation, step 3, with that value for K. So I'm going to say, at first I started off with Y is equal to K times X, if it's direct proportion. And then from there, they gave us the first bit of information. I could find K. Let's say K is equal to 5. So then in step number 3, now I'm going to write Y is equal to 5 times X, okay, once I find K. And then step number 4, they're going to give you some more information so you can actually solve the problem using that K value that you just found back there in steps 2 and 3. All right. Well, let's see how it works out. All right. So here, Y varies directly as X. So when I see that statement, so step number 1 says that I'm going to write this as Y is equal to some constant K times X. Do you see that? Y varies directly as X, right? And then it gives you, here's the second step. They give you some first bit of information. Y equal to 98 when X is equal to 7. They're giving us that, step 2, so we can find K. So step number 2, we have 98 is equal to this K times 7. I'm just going to write 7 times K. Okay? So now, from this step, we want to solve for K. So here I get K is equal to 98 divided by 7. What is that, 14? So step number 3, I have y is equal to 14 times x. Now step number 4, now you see that last step is this last statement, the sentence in the problem, it says find y when x is 12. So now we can do that because we know what k is. So step number 4, we have y is equal to here. I'm just going to write this now. When x is equal to 12, I'm going to replace the x with 12. So I have y is equal to here 14 times 12. What does that give you? $168. Okay, does that make sense? This is just very straightforward. Now, we'll give you about 3 or 4 of these kind of problems, basic, so that you get the model, that you're able to write the model the correct way. And then after that, we give you the problems that we really want to give you, which are the real juicy word problems. The last problem here, folks, is a problem on what's called your BMI. Has anybody ever heard of that before, the BMI? Your body, whatever, some kind of... Yes, thank you. What's it called? Body mass index. Look, when you get to be my age, you hate that number, okay? Because it affects your dang on insurance and all that, you know, man. I'm like, dang on it, crap. You know, I'm not doing that bad. But anyway, so your body mass index, your BMI has to be between, you know, certain numbers like 20 to 25. I'm like, why so low? You know, and why is my number way up? You know, so it's based on 2 things: based on your height, and then it's based on your weight. So I think my BMI is like close to 30, which is bad. So the doctor and the nurse said, well, you got to lose about like 30 pounds. I said, 30 pounds? Man, I'd be like a toothpick if I lose 30 pounds. You know, and so, you know, you go to a doctor in the hood and they're like, you want to live, you want to die, you know. okay, dang, got it, you know. So man, I'm out there running, you know, man, you're watching what I'm eating and stuff. Man, lose like 1 pound, right? You know, so, and I've been like, I don't know, 4 or 5 years just trying to get the weight down. But then I thought, all of a sudden, I had another idea. Another fresh, cool, mathematical idea. And I thought this. Maybe I can get taller. But anyway, let's get back to the let's get back to the math, right? So now, you can have variation problems, and they talk about a particular power. It may say that one of the terms is raised to the 3rd power, is cubed, whatever. You just put the 3rd power, you know, on that particular term. Make sure you put that, whatever they're talking about the power, you put it on the right term. So here, this is just an example model. Y varies directly as the nth power of x. So x is said to be raised to the nth power. So we'll write that. It's direct proportion, so is y equal to some k, that constant, times x to the nth power. It could be indirect, and then the power may go downstairs, but just based on how it's worded. It could be a power, that's a whole number, we call those just regular powers, or it could be a power that's a fraction, which we call radicals. Like if this x to the 1/2 power, that's just the square root of x. So you may see those statements in the problem. Let's see. Here, I basically just classify 3 things: direct variation, indirect variation, and joint variation. The one with the power, that was just, you know, something for free. So here is the indirect or the inverse variation. So another word for this would be indirect. And the indirect just simply goes with the opposite from that very first one that was called a direct variation. So indirect, with direct variation, indirect variation. So indirect is just when two terms varies inversely. And you see the model there. If y varies inversely with x, that simply means that y is equal to some k divided by x. So when we see the English, then this is just telling us how to write it out, okay? Again, that k is that constant of proportionality or the constant of variation. All right, here's a problem for for y varies inversely as x. So I'm just doing the steps. So I'm going to read, it's that first sentence, read that first sentence, translate it into math. So here this is y varies inversely, so that's y is equal to some constant upstairs divided by x, because it says y varies inversely as x. Right? So that's step number one. Step number two, look at the second sentence, and they give us some information. They're simply wanting us to find k. So it has that y is equal to 12. This is equal to x over, and 7 is equal to x. So from here, I get the value for k, 12 times 7. All right. What is that? Okay. Step 3, replace k with what we just found in step number 2. So I have y is equal to 84 all over x. So then step number 4, here it says now find y when x is equal to 2. So step number 4, I have y is equal to 84 all over 2. So y is equal to 42. Okay. Is everybody okay there? Okay. Now, joint variation. This is where we put all the apples and oranges and maybe some grapefruit, some cucumbers in the basket. So we can extend direct and indirect variation to more than two related terms. So here we can talk about y varies directly to x and y. Again, they all are going to involve some constant. So if z is varying directly with x and y, that means that they're all going in the same direction. So I get z is equal to some constant times x times y. You remember the idea of inverse or indirect means that if direct means upstairs, indirect or inversely means downstairs. Right? So if I see the term that a statement is inversely, then I'm going to put it downstairs. That is in my denominator. So z varies directly with x. That means that x is going to be upstairs, and indirectly with y. So that means that y is going to be downstairs. Right? So we call this a joint variation. And you can have a whole cluster of these guys. Right? They can just keep writing the statement on out. This is directly to this. This is indirectly to that. This is. They may even put statements like the sum, which means you got to add something. And I think we run across one of these, and I'll show you. Let's see. Okay, here, y varies directly as x. Let's just write this out. So y varies directly as x, and then it has that inverse. So that means it's going to be downstairs. So here I'm going to say, so since something is direct, that means it's upstairs, right? And then here the inversely, that means that term is going to be downstairs. It says the square of z, so that means z squared, right? So here y, let's go back to the first part of the sentence. Y varies directly as x, so that's some constant. The constant is always in the numerator. The constant is always in the numerator. So this is some constant times x. X is upstairs, divided by here, this z squared. You see how that worked out? Okay. Basically, we just took that first sentence, and we just translated that first sentence into English. So here, y varies. That means y equal to, the word vary represents the constant. So y is equal to some constant, is directly as x. That's going to be the constant times x. And then it says inversely downstairs. In my denominator, what's downstairs? The square of z, z squared. Okay. So now so it's like this first step, second step, third step, fourth step. And what steps am I referring to? I'm going back here to these steps here. 1, 2, 3, 4. Okay. So step number 2, I'm going to take that second sentence and look at what they give us. And they give us that information in that second sentence so that we can find k, so we can determine the constant. So here they give us y. They say y is 8. So I'm going to say 8 is equal to, I have that constant k, and that's times 36, because that's x. And then that's divided by, here it says z is 6, and that's 6 squared. Right? So when I simplify that, I have 8. Now, 6 squared is 36, so I get 36 divided by 36. They cancel out. So step number 3, since I know what k is, so I write y is equal to 8 times x all over z squared. And then step number 4, well, they give us some more information over there. It said find y when x is equal to 3 and z is equal to 12. So here it says find y when, it says, just rewrite the equation. When x is equal to 3, c is equal to 12, you find what's left. Find y. So here we have y is equal to 8 times 3 all over 12 to be squared. So this is 24 over, that's 12 times 12. What do you get? Well, yeah, that's what that is, right? So this is 2 times 12 over 12 times 12. So the answer that we want is 1 over 6. Okay. So that's just an example of the joint variation. Okay, so now let's work some more problems. All right, I give this one for you. So this is one of those joint ones. So it says y varies jointly as a and b, and then inversely as the square root of c. So make sure that first step we get that right. We want to be able to write that equation out. All right, so when you wrote that out, what did you get for that first step? Emmanuel? What did you get for the first step? Sir? You did it in your head? All right. So step number one, y varies jointly as a and b. And so we have y is equal to some constant k times a times b. And then it says inversely as the square root of c. So that's inversely, that's going to be divided by the square root of c. Okay. Step number two, look at that second sentence, and they tell us that y is 16 is equal to, they tell us that a is 4, that a is upstairs, and b is 2, that's upstairs, times k, and that's divided by the square root of, they give us c to be 16. So we simplify that, we get 16 is equal to 8k all over 4. And so we get 2 times k is equal to 16. And so there that gives us k is equal to 8. So step number 3, we can write the equation y is equal to here 8 times a times b all over the square root of c. And then that last sentence, they say find y. They tell us that a is equal to 6, b is equal to 4, and c is equal to 4. So we get y is equal to 8 times 6 times 4 all over 2. And so y is equal to 4 times 6 times 4. That's 16 times 6. And so we get y is equal to, what is that, 96? Okay. Any questions? Yes, ma'am. You had a question? Oh, okay. I saw your lips move. I thought maybe you had a question. Okay. Everybody good with that? Okay. Mm-hmm. Okay. All right. Okay, write the statement as an equation, then solve. Solve the equation for n, use k as the constant. It says here, g varies jointly as y. Let's see if we can write that out. Step 1, g varies jointly. So we know we got a constant jointly, and we know we have some things going on when it says jointly. It says as y, as h, excuse me, I'm sorry, and the sum of n and s. So that's going to be, when it says jointly, then I know that is multiplication involved. So I have something times something else. I have something, which is the h, times the sum of n and s. The word sum means to add, right? Plus. So here this is times the parentheses n plus s. Again, g varies jointly as h, that means that g varies, that's equal to some k. Jointly, that means that two things are going to be multiplied. What are the two things? It's h times the sum. H times, here, the sum in parentheses of n plus s. So here, write the statement as an equation, use k as the constant. So they just want what we have for step number 1. So here g is equal to k times h times n plus s. And then it says solve the equation for n. It's already given as g equal to, but now they ask solve for n. No problem, we just use our math. That is, we use our arithmetic and algebra to solve. So I have g is equal to, there's a couple of ways you can get it. Let me just give you the simple way, I think. We're trying to isolate n, that is, solve for n. So I'm going to divide both sides by that k times h. You understand that the strategy in mathematical science in terms of just solving for something is how the military built its strategy of divide and conquer. And so do you understand that for officer training school, mathematics is one of the highest courses that those cadets and students must pass? They have to take not just the algebras, but also the calculuses, because it forces people to think strategically. So, Alexander the Great, his tutor, a great mathematician, told me, trained Alexander in the arts of mathematics. And Alexander used the mathematics to build his military empire. So I want to get n by itself, and to get n by itself, I want to get to it by using the laws that I know. So I'm going to divide both sides by k times h. So I have g divided by kh is equal to k times h times n plus s. Now, for some of you, you don't even have to write this. You can just say g divided by k times h is equal to n plus s. You already see it. Now just one more step, since I'm getting n by itself, is to subtract s on both sides. And if you see that, then you can just go ahead and just write it. So I'm just going to say n is equal to g over kh minus s. That's the answer. It's another way of solving it, but I think this is the easier way. The other way is you have to be mindful of the least common denominator. So. You remember doing stuff like that back in high school, algebra? Yeah. Okay. When, about just a show of hands for some of you, when you had algebra in high school, was that during that COVID pandemic where you were taking it at home? And did that affect anybody here?
It was a year prior to that.
A year prior to that? Okay, gotcha. I know some people were affected by that. All right, here's the good stuff. So here's where we've been trying to get to. Just the problems that are just problems of life, right? Because problems of life are solved by mathematicians like you. Let's see. An alligator's tail length, t, varies directly as its body length, and you can see that an alligator with a body length of 3.2 feet has a tail length of 2. So here it says that first sentence gives us the equation. It says that the tail length t varies directly as the body length b. How would I write that equation for step number 1? What would that say? Talk to me. We talked about 3 models today. We talked about direct variation, talked about indirect, and talked about joint. If it's direct variation between y and x, that's y is equal to some k times x. That's direct. If it's indirect or inversely, y is equal to some k divided by x. Right? And if z varies jointly with x and y, that is that z is equal to some k times x times y. So those are the three models we talked about. So for this problem, this is a what of the three?
A direct.
It's a direct. Very good. So since it's direct, do I have the variables that I need to compare? What two variables are we comparing?
The body length and the tail length.
All right. So the tail length and the body length. Very good. So that's t is compared to b, right? So now how would I write the equation? Carmen, I was reading your mouth. You had your mouth open. I thought you were going to say it. Then you just... I was getting excited. Oh. So how would we write that? When you were in elementary school, did your teachers ever tell you all to put on your thinking caps? Did y'all remember that?
Yeah.
So class, let's put on our thinking caps. Well, I'm just looking at that first sentence and I'm just reading it as it is. It says t varies directly, that's some constant, directly as b. That's it. Step number 2, I look at the second sentence. There, they're going to give me information so I can determine k. Step number 1. Step number 2. It says that the body length, that's representing b, is 3.2, and the tail length, that's t, that's 2. So I get 2 is equal to, here, 3.2 times k. That implies I can solve for k. So k is equal to, on our handy dandy notebook calculator, 2 divided by 3.2. So I get 0.625. 0.625. So now, step number 3, I have t is equal to 0.625 times b. Step number 4. Solve. What is the tail length when you're given that the body length b is equal to 4? So t is equal to 0.625 times 4. .5, and the units that they're given in are in feet. That wasn't so bad, was it? Okay. All right. Use the 4-step principle for solving the following variation problem. And we've been talking about for every problem we've been talking about these 4 steps. Okay. So it says the height that a ball bounces varies directly as the height from which it was dropped. So since they're both talking about height, I'm not going to use h because that just confuses the heck out of me, right? But I will use b for bounces and let's say d for dropped. Okay. So that first statement here says the ball bounces, b varies directly as some constant as the height of which it was dropped, that's times d. See how we built that? Typically look at that first sentence. We should be able to, from the first sentence, build the equation. The equations, watch this. You remember going back to the department store years ago and they would have, I think it was called the mannequins in the window, in the shopping window? and they have like the nice clothes and you know the mannequins. What do you call those mannequins? What are they doing?
Posing.
Good. What's another word?
Advertising.
Okay. It's even a better word. Yes. This starts with an M.
Modeling.
Yeah, thank you. So, very good. These mannequins model, and then you have these professional models. They do it for, I mean, that's their career. And what I hear is a pretty hard job. Well, in mathematics, we have models as well. Now, they're not as pretty as those girls that walk on that stage, not as enticing as those mannequins there in the department store at J.C. Penney. Do they still have J.C. Penney? I don't know, but that was my store when we came up. J.C. Penney and Sears Roebuck. Got to have that Mr. Roebuck on there with Sears. Hot tomato. We can talk about history. But anyway, math has models. And in math models, you know what they are? Just an equation. So when you see an equation in mathematics, that equation is actually modeling something in nature. Not all equations do. But this equation right here, they're talking about the ball bouncing varies directly with the height of which it was dropped. So we can model that based on here, the mathematical statement. So this statement here, in step number 1, class, that's called a model. It's called a mathematical model, and a mathematical model is just an equation, okay? Just my imagination. Step number 2. A tennis ball dropped. So that's see how I put my letters together. So when I see drop, that's D. So I'm going to replace the D with that 9 inches. And it bounces. See, I put B for bounces, 7.2. So I got 7.2 is equal to K times 9. They give us that so we can solve for K. So on your handy dandy, is Blue's Clues still out?
Yeah.
All right. Maybe I shouldn't ask my other question. Do you still watch Blue's Clues? But anyway, you know, I wanna watch the old cartoons from like the the 50s and the 60s with Bugs Bunny and all those guys. Man, they were always good. Is that 0.8? Is that what you get for K? 0.8? Okay, thank you. Carmen, did you got it? Okay, thank you. You're not just moving your lips this time, right? Okay. All right. So here, why does my 3s look like 8s? I did not have my Cheerios this morning, Mr. Devin. Did not have my Cheerios. So here I get B is equal to, that 1 hour threw me off. That 1 hour threw y'all off?
Yeah.
Yeah, I was okay for Sunday, and yesterday I can get up whenever I want to, but today it was rough. Maggie, what's your secret? Nothing. B is equal to 0.8 times D. What's your secret for getting up and being on time, Miss Maggie? So, it says now, for what height was the tennis ball dropped? That is, I'm looking for D. If it bounces 56 inches. So it bounces 56 inches. That's equal to 0.8 times D. See that? So here, for this problem, we're solving for D. So just divide 56 by the 0.8. You get 70. And it looks like it's in inches. Everything is in inches. You got to make sure that you pick inches in there. Okay. Does that make sense? if all men, had identical body types, their weight would vary directly as the cube of their height. The tallest person reached a record height of 8 feet, 11 inches. I don't know if you all remember seeing that guy. I remember they had him on like in Guinness Book of Records, and this was probably, I don't know, maybe in the 30s or 40s. Very tall guy, but he had some disorder that made him grow so tall. But in that disorder, he died very early. He was like, I think it says it here, he was like 22 years old. But if you see the picture of him, he looks like he could be like, I don't know, 60, 58 years old, just because of that particular disorder. So the tallest man reached a record of 107 inches before his death at 22. If a man who is 5 feet 10 inches tall, that means that's just 70 inches, with the same body type as the tallest person, weighs 190 pounds, what was the tallest person's weight shortly before his death? Okay, so we read it. That's good. You read the whole thing so that we kind of get a feel for what's going on. But when you dissect it, you go back to the first sentence, and then you take that first sentence, and then you translate that. So let's go back. First sentence: if all men had identical body types, they're just saying that they're comparing apples to apples. Their weight would vary. That's it. Their weight would vary directly as the cube of their height. So let's let the weight equal to weight. Let's just call it W, because we're mad scientists and we know how to ascribe variables to things. So, and let's call the height, you got it, H. Okay. So, step number 1. It says the weight varies directly, K, right, as the cube of the height. That's times H to the third power. Is that what you were thinking about, Emmanuel?
Yeah.
That's my friend. All righty. So, step number 2. The tallest person reached a height of 107 inches. So we're going to be using inches. We'll take the feet and that kind of thing and convert to inches. So the tallest person was 107 inches before he died at the age of 22. Here, if a man who is, now they give us that next sentence, that's like a clue, but we can't use it right now, but maybe we'll use it later. Let's keep reading. If a man who is 5 feet 10 inches, that is 70 inches as his height, and he weighs 190 pounds. From there, they give us 2 things to compare. From there, we can find K. So here I have this person here. If a man, I have this man, he's 190 pounds, is equal to. Now, the interesting thing about the constant, because it looks like we're comparing weight to height, that constant, if we could actually figure out what it is, and which we do, but you'll get its units, and its units would be based on canceling out to make sure that at the end result we're comparing, say for example, weight to weight or inches to inches. So that constant, man, it has it all. It has everything you need. So here this is equal to K times, now that person's height is 70 inches, that's raised to the third power. So K is equal to 190 all over 70 to the third power. So on your calculator, we find that. very small number, 0.00. Looks like it's 3 zeros. I'm just going to write it all out. 554. Looks like 3 zeros. So, step number 3, this becomes W is equal to 0.000554 times H to the third power. So now, step number 4. We want to solve something, but what? It says at the last end of the sentence, what was the tallest person's weight shortly before his death? So what was the tallest person's weight? But they give us his height. So that is, so W is equal to this 0.000554 times here, the tallest man, he was what, 107 inches? The tallest person, that second sentence, reached a record height of 107 inches. So this is 107 to the third. Now, I got my weight to be, it was a very strange number. Its weight was 678 point, it says round to the nearest whole number. So that'll be 6, well, let me just write this, 0.595, and we'll just say that's 679. And here that's going to be in pounds. And you'll put that number now. What I should have done, and you could do this too, I should have Googled that gentleman's information, because I'm sure it's out there, to actually see, you know, if there's anything online that talks about his weight, you know, when he died. I don't think he was over 600 pounds. But here's something to think about, you know, because if it's the same person I'm thinking about, he was tall, but he was slender. If it's the one that I can remember, you know, from reading years ago. But that's funny too, because there are people who are tall and slender, but they weigh a lot. Sometimes we think just because the person is tall and slender that, you know, but you put them on the scale, you think about a person, you know, he's like 6'10", and you say he's, you know, he's slender, but then if you shrink him down to my height, which, you know, okay, you'll say, man, you know, he's pretty big. So, anyway. All right. I'll leave that one for you. There's one more. This is the one with that BMI that I had told you about. This is like a real problem, man. You know, and I know for our insurance, every year we have to go through this, and it's, you know, it's a depressing day when I have to go through that. So body mass index, or BMI, takes both weight and height into account when assessing whether an individual is overweight or underweight or overweight. BMI varies directly as one's weight in pounds, and inversely as the square of one's height. So let's see, we're talking about BMI. That's that second sentence that I'm going to translate. So I have the BMI. It says varies directly as one's weight. So I'm going to use W for weight, and then we'll use the height, we'll say H. So I think that makes sense. So here it says the BMI varies directly. That's some constant. It's directly as the weight. So some constant K times W divided by, inversely, that's divided by the square of the height. So that's H to be squared. All right. In adults, normal values for the BMI are between 20 and 25. I think that needs to be, re-examined. Values below 20 indicate that an individual is underweight, and values above 25 indicate that an individual is overweight. They use that for so much. They take that number and they can give these projections for diabetes and for heart conditions. I mean, it's crazy how they can take that. And I tell them, I don't believe you. No, I'm just joking. I try to go out there and do some running. So a person who weighs 180 pounds and is 5 feet, or that is 60 inches tall, has a BMI of 35.15. They're giving us that for a reason. They want us to find K. So here, step number 2, they tell us that a person weighs, let's get the BMI. The BMI is 35.15. That's equal to that constant and how much they weigh. The person weighs 180 pounds. And then it gives us the height. Person is 60 inches. That's to be squared. So we take that to solve for K. So K is equal to 35.15 times 60 to be squared all over 180. So here, this constant I get is 703. Is that what you get too? Anybody work that out in the calculator? 703. Just want to make sure I got it right. So here we get BMI. And I'll tell you what I did. I went and I sat here and computed mine too. And mine came out exactly to what that nurse told me. I was like, man, math don't lie. Because I told the nurse, go back and do it again. She was like, really? So this is 703 times W all over H to be squared. Now, the last sentence, use the 4-step, okay, to determine what the BMI is to the nearest tenth for a person who's 175 pounds and he's 6 feet and 2 inches. So that's 60 feet. What is that? In inches, 60 feet is what? Is that 72 inches? And then plus 2, that's going to be 74 inches. See, here the units are all in inches. So step number 4, you're looking for the BMI of a person who is 175 pounds. So we get the 703, which is the constant, times 175 pounds. And that's all over a person who is 74 inches. And don't forget, you got to square that. So 703 times 175 divided by 74 squared. So I get a BMI that I'm envious of 22, so it rounds to the nearest tenth, 22.5. So 22.5, and this person, old joker, his BMI is normal. Well, that's that.